What's up guys? This is Engineer Jack and this is Hydraulics. So today, yung lecture ni Engineer Jack is about the hydrostatic force on submerged surfaces. Now that we have determined how the pressure varies in a static fluid, we can examine the force on a surface submerged in a liquid. And in order to determine completely the resultant force acting on a submerged surface, we must specify, number 1, the magnitude of the force in kilonewtons or in pound force, number 2, the direction of the force, and number 3, the line of action of the force. So for example, meron tayong water surface or liquid surface, and ito yung triangle, this indicates that this is the surface of the liquid. So for example, meron tayong rectangular plate na meron siyang dimension na letter B for base and H for height. So yung thickness niya medyo manipis lang, and let's say that is letter T. So yung behavior ng force, yung F, this is the hydrostatic force acting on this plate, and itong force always perpendicular yan sa ating plate. So kahit naka-incline yan, basta yung direction of our force dapat always perpendicular to that plate. Pero guys, sa curved surface naman, ito rin naman yung behavior niya. So meron tayong dalawang component of our hydrostatic force. So meron tayong force at horizontal and force at vertical. Pero for this presentation, uunahin ko muna explain about this plate or rectangular plate kung naka-vertical position siya. So for example, ito yung plate natin na meron siyang thickness sa T, and yung top surface of our plate, naka-flush siya sa surface din ng liquid. And let's say yung this the y-axis na positive tayo, downward direction, and to the right, x-axis that is positive. So yung pressure natin, that is also equal to the unit weight times height, and makukuha natin yung pressure at the lowest point of our plate. So this, for example, ito yung magnitude niya, and syempre, 0 sa taas, kaya magkakaroon tayo ng triangular loading dito sa plate natin. So for example, kukuha ko ng strip in our plate para makapag-derive tayo ng formula para makuha natin yung hydrostatic force o letter F. So for example, kukuha ko ng strip, and itong strip, exaggerated lang yan. Actually, maliit lang yung strip, pero yung syempre, para makita natin, pinalaki ko yung konti. And yung thickness ng strip, let's say that is dy, differential of y. Kasi yung location of our strip from the water surface, let's say that is variable y. Kaya dapat, yung thickness of our strip, dapat naka-differential of y. So, pwede natin guys makuha dito yung hydrostatic force or the differential force in this strip. Kasi kung babalikan natin guys yung strength of materials, so meron tayong stress is equal to force over area or pressure equals to F over A. Pag inayos natin yan, pwede din natin sabihin na yung force that is also equal to pressure times area. So galing din naman yan sa sa calculus. So if we have differential force, equal din yan sa P times differential area kasi yung P natin that is constant. So pag in-integrate natin yan, babalik din naman sa F equals to PA. But in our differential area dito sa presentation, kung mapansin nyo, yung differential area natin is yung area of our strip. Na yung area of strip natin, meron siyang length na B and thickness sa dy. So yung differential area natin, that is B times dy. So we can also say that our differential force, that is kasi yung pressure, that is the unit weight of the liquid, times y, kasi yung y natin, ito yung location or ito yung distance from the strip to the water surface. Or equal lang naman yan sa unit weight of the liquid times height niya or location niya. And yung differential area nga natin, that is B dy. So pag in-integrate natin yan, the integration of differential force or dF equals to unit weight of the liquid times y times B dy. And yung limit niya is from 0 to h, or ito yung dadaanan ng strip in our area. So the integration of differential of force, that is force kasi matatanggal yung d, equals to the integration of this unit weight of the liquid times y times B dy. Okay lang naman ihiwalay yung B dy kasi yung B, that is constant, and yung liquid, unit weight of the liquid, that is constant din. So pag in-integrate natin yon, magkakaroon tayo ng unit weight of the liquid times B kasi constant yan, and yung variable y natin magiging y squared all over 2. So nasa rule natin yan sa integration from 0 to h. So substitute the value of h. So finally, meron tayong formula for our force, the unit weight of the liquid times B times h squared over 2. Pero guys, pwede ko hiwalay yung value of h. So pwede kong gawin na BH times h over 2. And this BH, this is the area of our rectangular plate. Kaya pwede kong palitan na letter A. And yung H hub naman, pwede kong sabihin that this is the H bar or this measured from the liquid surface to center of gravity. So yung center of gravity, syempre kalahati ng plate, and nagkataon lang na H hubs kasi yung top face of our plate naka-flush din sa water surface natin. Kaya nagkataon na yung H hubs, yun na mismo yung H bar. Pero not all the time yung H bar is H hubs kasi nag-iiba din yung shape natin and yung mga times din na yung plate natin hindi naka-flush sa water surface natin. So for this example, we can derive our formula for our plate na yung hydrostatic force acting on that plate is equal to the unit weight of the liquid times H bar times A, or the area of our plate. So, let's say this is the first solution. And tatandaan nyo, yung H bar nga, this is the distance from the centroid of the area to the liquid surface. Pero guys, personally, ginagamit ko talaga in any problem in solving the hydrostatic force, ito talagang ginagamit ko na integration kasi mas accurate to and especially mas madali to sa mga mahihirap na problem. So mamaya, explain ko kung bakit mas madali to and sa mga susunod kong example problems dito sa hydraulics. So, integration ko talaga ginagamit is yung F that is equal to the integration of P times differential area from 0 to H, and yung P nga natin, that is the unit weight of the liquid times H bar. And yung H bar natin, kung saan nakalocate yung natin, yung strip natin na kinuha, dapat from that location hanggang sa liquid surface, that is the value of H bar natin. Pero syempre, dapat naka-variable Y. So let's say this is the second solution, pero ito talaga yung recommended ko na solution, which is the second solution. And meron din tayong third solution in solving the hydrostatic force in our plane surfaces. So we can also say that the hydrostatic force is equal to the volume of the pressure diagram. Yung pressure diagram na sinasabi ko, itong diagram na to, kasi 3D siya, so itong galing yan dito sa pressure diagram, na pag in-3D natin, ito yung itsura niya. Pag sinolve natin yung volume of this prism, or this pressure diagram, automatic makakuha natin yung hydrostatic force. So yung F natin is equal to the area of the base, which is the triangle, times yung length niya or the thickness of the plate. So meron tayong 1/2 times P times H. Ito yung area of the triangle kasi meron tayong base na letter P times H din kasi meron pa tayong H dito. So 1/2 times P times H, that is the area of the base natin, times yung length niya for the pressure diagram. Ito yung B or the width of our plate. So 1/2 times the unit weight of the liquid times H, ito yung pressure, times H times B. Kung naalala nyo kanina, yung BH natin, that is the area of our plane. And yung H over 2 naman, H times 1/2, ito naman yung H bar. So babalik pa din tayo sa formula na unit weight of the liquid times H bar times A. So so you can use 3 solutions. And this time naman, ilocate naman natin yung F or the hydrostatic force. Saan ba siya nakalocate? From the liquid surface. So, let's say yung variable natin is Y. So, pwede tayo guys mag-moment at the top face of our plate. So, pag nag-moment tayo dito, so yung differential moment dyan is equal to the differential force times moment arm niya. So, force times moment arm lang yan. So, force times distance. And meron tayong value kanina in using integration na equal yan sa the pressure times the differential area. Yung differential area natin, yung area ng strip, which is the length niya is B, times yung thickness niya, dy. And differential force is equal to, yung pressure is equal to the unit weight of the liquid times yung H bar niya, so yung location ng strip from the water surface or liquid surface, that is the variable Y. Ito yung pressure times differential area na B dy. So ito, i-substitute natin dito sa equation na differential force times Y, magkakaroon tayo ng dalawang Y, kaya pwede natin sabihin na unit weight of the liquid times B times Y squared differential of Y, and saka tayo mag-integrate. So, pag nag-integrate tayo niyan, the integration of differential of moment is equal to the integration of the unit weight of the liquid times B times Y squared dy, and pag in-integrate natin ito, magiging Y cubed over 3. And yung limit niya is from 0 to H, so substitute natin yung value of H. So meron tayong value now na moment at the top surface of the plate is equal to the unit weight of the liquid times B times H cubed over 3. And kanina, na-derive din natin na yung force natin is equal to the unit weight of the liquid times B times H squared over 2. And yung Y natin, kanina kasi, di ba, yung moment natin is force times distance, pero yung moment arm natin is also equal to moment all over force. Na yung moment nga natin, na-derive natin na unit weight of the liquid times B times H cubed over 3 all over unit weight of the liquid times B times H squared over 2. So, cancel yung unit weight of the liquid times B. So, that is equal to 2H over 3. Or pwede din natin tingnan yung pressure diagram natin kasi yung hydrostatic force, nakalocate yan sa centroid of our diagram. So, kung triangle to, ibig sabihin, yung location niya from the top surface of the plate, that is 2/3 of the height of the plate. Or from the base naman, that is 1/3 naman. So, kahit hindi natin i-derive, makukuha natin na 2H over 3. Pero take note, for this example, kasi not all the time na rectangular and not all the time nakalocate yung surface of the plate sa surface din ng liquid natin. In other books, meron tayong tinatawag na eccentricity or letter E. Ito yung distance between the center of gravity naman to the center of pressure. Kasi yung center of pressure, ito talaga yung location of our hydrostatic force or F. And yung formula natin for letter E or the eccentricity, meron tayong centroidal moment of inertia all over the area times y bar. Nag-iiba yan na y bar, especially pag naka-incline yung plate natin. Pero kung naka-vertical position naman yung plate natin, syempre yung angle natin is 90 degrees. So, sin 90 equal to 1. Kaya minsan, pag vertical position, inequate natin yung y bar is equal to h bar. So, yung centroidal moment of inertia, pag rectangular yung plate natin, is bh cubed all over 12. And yung area natin is bh times yung h bar niya or yung y bar, kasi syempre this time, y bar equals to h bar na. So, yung location of the centroid from the water surface is kalahati ng h, kaya h halves. So, simplify natin. That's bh cubed all over 12 all over bh squared all over 2. Magkakancel dito yung b and maiiwan is h na lang and sa baba is 6. Kaya h over 6. Or pwede naman natin tingnan ulit yung pressure diagram natin kasi nga nakalocate yung F natin that is 2/3 of height from the water surface and yung location naman of center of gravity that is h halves din. So, ibig sabihin yung difference of this is yung value of E. Or 2h over 3 minus h half, dapat h over 6 din. In summary, ito talaga yung nire-recommend ko na pag-solve ng hydrostatic force natin and yung location of our hydrostatic force from the center of gravity or yung eccentricity niya, which is the distance between the center of gravity to the center of pressure. Ay yung formula ko is the differential of moment all over the differential of force minus hcg. Ito yung hcg, ito yung height from the center of gravity hanggang doon sa top surface of the plate. And yung moment natin, dapat mag-moment tayo sa top surface of the plate, hindi sa top surface of the liquid. Take note, sa top surface of the plate. So ngayon, mag-solve tayo guys ng example problem. So basahin ko muna yung problem. A vertical rectangular gate with water on one side is shown in the figure. Determine the total resultant force acting on the gate and the location of the center of pressure. So first solution, pwede natin gamitin guys yung na-derive natin na formula na. So, the force is equal to the unit weight of the liquid times h bar times A. Yung unit weight of the liquid natin, ito yung gagamitin natin is the unit weight of water kasi yung liquid na ginamit dito is water. And that is 9.81 kilonewton per cubic meter. Times yung h bar natin, syempre, dapat yung location of the centroid from the water surface. So, meron tayong 3 meters and kalahati ng 1.2 kaya 3 plus 0.6 meters. Ito yung h bar. And yung area of our plate na 2 meters times 1.2 meters. So, pwede nyo guys i-pause yung video and i-calculate yung hydrostatic force. And the value of F is 84.7584 kilonewtons. And this is the first solution. Second solution naman guys, we can also say that our hydrostatic force is equal to the integral of PdA and yung P, this is the pressure, and yung limit niya is yung dadaanan ng strip. So from 0 to 1.2 kasi ito lang yung height of our plate. So for example, kuha ulit ako ng strip and yung thickness niya, syempre lagi kong ginagamit is differential of Y kasi yung location niya from the top surface of the plate, that is variable Y. And meron tayong value from the top surface of the plate from the water surface, meron tayong distance sa 3 meters. So, yung h bar natin is the location of the strip from the water surface. So, yung h bar natin, that is 3 meters plus y. So, yung pressure nga natin, that's the unit weight of the liquid times h bar times differential of area. And yung h bar natin this time is 3 meters plus y. And yung unit weight of the liquid is the unit weight of water na 9.81 kilonewton per cubic meter. And meron tayong differential area na yung area ng strip, which is the length niya is 2 meters and yung thickness niya is dy. Kaya 2 dy yan. And yung limit niya is yung dadaanan ng strip. So, yung dadaanan niya is from 0 to 1.2 meters lang. So, pwede nyo guys i-pause ulit yung video and i-calculate yung integration na yan using your calculators. And dapat pareho lang yung value na nasolve natin using formula kanina na dapat yung F, that is 84.7584 kilonewton. And last solution naman, we can also use the pressure diagram. So, the volume of the pressure diagram, ito yung the value of F. So, kung mapansin nyo dito sa part na dito, ito yung pressure diagram acting on the plate. Hindi talaga sa triangle kasi meron tayong pressure at the top surface of our plate. So, first, meron tayong pressure dito of 0.1. Let's say this is 0.1 and meron tayong 0.2. Itong kulay white na bilog. So, para masolve natin yung pressure at 1, that's the unit weight of the liquid times yung height niya, elevation niya from the water surface. Sabihin natin that is H1. And yung P2 naman, the unit weight of the liquid naman times H2 or yung location niya from the water surface. So yung P1 natin, that is 9.81 times 3 meters. Kasi yung 3 meters, ito yung location from the water surface. And yung P2 naman, that is 9.81 naman, kilonewton per cubic meter, times yung location niya from the water surface, that is 3 plus 1.2 or 4.2 meters. So yung value natin for P1 and P2, meron tayong 21.43. Dapat naka-kilonewton per square meter kasi dapat naka-pascal or kilopascal. And 41.202 naman para sa P2 na naka-kilonewton per square meter or kilopascal. Pag in 3D ko guys yung pressure diagram, ito yung itsura niya. And pag sinolve natin yung volume ng pressure diagram, masasolve na natin yung value of F. So, F equals to the area of the base ulit times yung length niya or yung width niya is meron tayong B. So, yung area of the trapezoid times B and the area of the trapezoid, that is P1 plus P2 all over 2 times yung length niya is H times is yung width of the plate times B. So, substitute the value. So, meron tayong P1 na 29.43 plus yung P2 na 41.202 all over 2 times yung height niya which is 1.2 meters times yung length of the pressure diagram na 2 meters kasi ito yung width of the plate. So, pwede nyo guys i-pause ulit yung video and i-calculate. And that is also equal to 84.7584 kilonewtons. And sa location naman for our center of pressure, hindi kasi dito sinabi guys kung anong reference kasi pwedeng reference niya is from the top surface of the plate or sa top surface of the liquid. So let's say, yung location niya is from the top surface of the liquid. And equal yan sa H bar, or yung H bar is the location of the center of gravity from the water surface plus eccentricity. And yung H bar natin, that is 0.6 plus 3 meters kasi kalahati ng 1.2 plus 3 meters, that is 3.6 meters. And yung E naman, we can use formula na IG over A Y bar. And yung Y bar natin, that's equal to H bar pag yung plate natin naka-vertical position. And yung IG natin for rectangular, that is BH cube all over 12. So, dapat tatandaan nyo yung mga centroidal moment of inertia of our shapes. Dapat tatandaan nyo yung formula for centroidal moment of inertia. And yung area natin, that is BH. And yung H bar natin is yung kalahati ng plate na H halves plus yung location of the top surface of the plate hanggang sa surface of the liquid, that is 3 meters. So, magkakancel yung B natin and magkakancel yung H natin. So, may iwan natin dito sa taas. 2 na lang. So, H squared yan. So, H squared over 12 all over H over 2 plus 3. And by algebra, yung H over 2 plus 3, pwede sabihin natin na H plus 6 all over 2. And H squared all over 12 times 2 over h plus 6 kasi ito yung rule natin sa fractions, yung denominator natin pag fraction din, so magiging reciprocal nun, and multiply sa numerator. So h squared over 12 times 2 over h plus 6. That is also equal to the h squared all over 6 times h plus 6. So substitute the value. So h is 1.2. Kaya squared all over 6 times 1.2 plus 6, and that is 0.033 meters. So finally, man-solve natin guys yung location of our center of pressure na yung galing yan sa CP from the water surface. So equal siya sa h bar plus E, na yung h bar is 3.6 and yung E natin na solve is 0.033 meters. So yung sagot is 3.633 meters. And this is the answer for this example problem. So that's it. Thank you very much and have a good day.